Okay, so there's a bakery and it has a 50-foot by 31-foot lot, and that's going around the entire lot. That's including the grassy area, it's including the parking spaces, and it's including this driving kind of area too. Okay, that's their whole thing. Now, the 4 parking spaces are congruent parallelograms, and the driving region, this right here, is a rectangle. And then there's 2 areas for flowers that are congruent triangles. So they give us instructions for A. They say find the area of the paved surface by adding the areas of the driving region and the 4 parking spaces. So let's do that first. Let's find the area of, let's first find the area of the um, driving area, this right here. Well, since it's a rectangle, it's pretty straightforward. You've got a width of 50 and a height of 15. So you can say 15 times 50, 0 placeholder, 5 times 5 is 25, carry the 2, 5 times 1 is 5, plus 2 is 7. So you've got 750, and what is it? Well, they were each in feet, so it's 750 square feet. I'm going to write that in there, 750 square feet. Okay? Now, let's find the area of one of the parking spots. Okay, well, we know that it's got a width of 10 because it's indicated right there in red, this right here. Okay, each parking spot is congruent, so we know that. Now, what's the height of it? Well, look over here on the right-hand side. This whole height is 31, and if you were to take away this length of 15, you would find out what that height is. Okay, and if we do 31 minus 15, you can do that in our head. That is 16. So we can label it as a height right here of 16. Okay, great. Well, if that's 16 times 10 and we're doing base times height, then what is 16 times 10? It's 160. And so we can say that this space has 160 square feet of area. Okay, great. Well, they want to know what's the area of the paved surfaces, and they say uh, add the driving region, which we know over here to be 750, and what's the area of all 4 spaces? Well, we found each one space is 160 feet, so I'm just going to do 160 times 4, and I get 640 feet squared. Okay. Well, we also could have, just to be clear, we could have taken the whole parallelogram as a big single thing instead of individual spaces, and we could have had a 40-foot base by 16, and that would have jumped us straight to there. Okay, but they want to know what's the area of the whole paved space. So what we need to do is add those 2 numbers together, and when we do that, we get 750 plus 640 equals 1,390 square feet. Okay, so we've got that as an answer. Now, that was A. Now it says describe another method for finding the area of the paved surfaces. So what I'm going to do is I'm going to erase the marks that I've already got here. We've got those numbers down on the bottom. But the one mark that I'm not going to erase is that green height of 16. Okay, I'll get to why I'm not doing that in a second. Okay, what we would be able to do in this, and I'm just going to draw a line here. Just give me a second, sorry. Draw that line to separate it. And then what I'm going to do is say, what would be the entire area here of this whole thing? Okay, well, that would be 31 by 50. Let's calculate it. 0, placeholder, 5 times 1 is 5. 5 times 3 is 15. And we've got an area of 1,550 square feet. Yeah? Now, we could, if we could calculate what the area of the planters are, these spaces right here in green, and we could just take that away and say everything that's left is paved. Okay? So, and in fact, we can go one further and say we could push these two triangles together. Since they're congruent, they're basically two halves of a rectangle. So what does it measure? Well, this whole thing measures 50, right? From here to here to here to all the way across is 50. And we know each of the parking spaces is 10. This is 10, 20, 30, 40. That means from here to here is 40. And if the whole way is 50, what does this leave this length to be? That makes that length 10. Okay? So we could find the two triangles as 16 times 10 and then take 1/2 of that, but then we double it because there's two of them. So let's not even bother to do 1/2 of it. Let's just push them together. Imagine these two coming together to just be a rectangle. That is 10 by 16. And what is that? 10 by 16 is 160 feet squared is what that planter spaces are. So let's take those away, minus 160. And when we subtract them, we say borrow from that. 15 minus 6 is 9. 4 minus 1 is 3. That 1 comes down. And we've got 1,390 feet squared. And notice these two values, because part 3 says use your method for part B to find the area, then compare the answers. Notice that those numbers are exactly the same. So describing another method, B, is to say find the area of the whole big rectangle and then subtract away the planter spaces. And as you can see, comparing those two numbers, we get the exact same area no matter what. So that's it. And I should just add, this is a common thing when you're calculating areas, is to sometimes it's easier to calculate the larger area and then subtract away the part that you don't want to include in the area you're looking for. Just another tool in your toolkit for figuring out the area of some odd shape.